Yo, what's up? Good morning. I'm just gonna jump right into this. We're gonna try and fix the screen space reflections today. I really don't want to. I want a good result, but I don't want to put more time on it. We have it in an acceptable state. We just have to reduce the artifacts pretty much. And last Friday we introduced a second pass, which I'm actually going to disable right now, because we're going to take a quick look at the first pass once again before we check the second pass. So the idea was that the first pass is a rough pass with big steps, and the second pass is a more detailed pass. So the rough pass finds interesting points. We score them based on some points, ranked them based on some score, I mean. We take the best one and do a second pass on it to find the exact point where we have an intersection. Unfortunately, it still doesn't work that good, but let's see here. It could be multiple different things, but one of them is most likely the score here. We're gonna see one thing. Right now we check. We take the difference between the depth let's see, we take this is good. So but I'm a little bit uncertain about this. So basically we have the ray we take, which we interpolate the depth of the ray. We have the depth from the previous iteration, check which one is smallest, and then we did a comparison like this. But I wonder if we want to do a comparison like, let's see here. So we have scene depth in view space. We have previous depth and current depth, and we have them sorted in depth bounds. This is the smallest one. This is the biggest one. I wonder if we want to do something like I'm just thinking if we want to change the order of this one. But so previously we had the smallest depth minus depth threshold first pass is less than or equal to scene depth, and scene depth is So we pretty much check if scene depth is between the lower bound and upper bound. But we're gonna try some different things here today. One I want to try as well is storing the scene depth of the previous as well, and as soon as we get a change, so either the previous one was bigger than the scene depth and the new one is smaller than, or the opposite, as soon as we get something like that, we mark a hit. But let's try. Depth bounds. Dot y if it's bigger than Yo, good morning, Harukanan. Hope you had a wonderful weekend, man. If depth bounds y, so the bigger one is, let's see here, if it's closer to the camera than if it's closer to the camera than scene depth in view space, so we want it to be smaller, right? Yes. Or actually, if it's further away, so if it's bigger than scene depth in view space plus said thickness, which is now called depth threshold first pass. So if the current depth, or the biggest depth of the previous and the current is, if this one is further away from the scene depth plus the previously named thickness but now threshold, or depth bounds dot x, so the smaller one of these, so the one closest to the camera, if that one is less than scene depth. Let's try this, return 1. Which gives us a intersection all the time. Why? Of course. Yeah, this one is rough. If this one is bigger than, this is important. But I want to do this. Scene depth minus, and this one is, so big one is but this is gonna be true so many times. Now I think we're gonna try this actually. Let's see here. Previous depth vs current depth vs, and then we're gonna have float previous depth scene. Fuck, do I want to do it like this? Fuck, we're gonna get some bad intersections if we don't care about distance to the object either. Yeah, that's true. But if we do this in a rough way and we rely on the second pass, it should probably be okay. Previous depth scene, we're gonna take do it like this. So current depth vs current depth scene, and then we do I wonder if we want to do like this. If current depth scene is less than current depth vs is not equal to previous depth scene less than previous depth vs. We have 2 points and we want one of them to be in front and the other one to be behind. Geometry. If that's true, we return 1. And finally, okay, that's good. Although we have pretty good performance on rough properties, but not a big fan of this. Maybe, and we have the same issue here, but that's okay. Maybe our second pass will sort it out, or that's what I hope. Let's see, there we have plane. What do we have? We have a step length of 20, so that's pretty much 20 pixels we're moving. And we have good performance now because 25, 30. The worst thing with the finding the best score approach is that we're gonna run through the full length of these rays. And then we do this. Let's see. Score should be pretty easy to calculate here. We just do. We have best intersection score, best intersection step number. So we just do float score is equal to min. Actually, when we do it like this, we don't care about thickness either, which is oh, fuck it. Min of apps between current depth seen minus current depth VS and previous depth seen if score is less than best intersection score, best intersection score is equal to score, and best intersection step number is equal to step count. For now, I'm gonna return best intersection score here. Yo, what's up, Derek? Sorry I'm a little late, no problem at all. Hope you had a wonderful weekend, man. We don't care about thickness in this solution. I don't know if that's a good or bad thing. We're probably going to care about thickness down here, but yeah. Okay, so I want to visualize best intersection score just like we did last Friday. Let's just visualize it like this for now. Return inverse lerp between. I want white to be the good one, so let's do depth threshold first pass 0, and then we take best intersection score. And what do we have? Depth threshold first pass 0. Okay. Yes, the first best intersection score needs to be something other than 0 here as well. So let's go with 100. And then we do depth threshold first pass 0.1, 0.1. Okay. This score is extremely rough. What do we have on performance here? 240, that's way better than I anticipated. Second pass will hopefully take care of this one. Second pass will hopefully take care of these as well, so we probably reflect on this here, and then we move behind the hand, and that's the closest we're ever gonna be to an intersection. Although does the result we're seeing here make sense? I want to add my sphere as well. Yeah, this is what sucks with this solution, I would say. Plane. Let's go 1, 2, 3, yeah. Or maybe it's not too bad. I just have to say as well that this one, yeah, of course, yeah, we're gonna get true for this one. That's true. Okay, second pass is gonna have to be working overtime here. What's up, UBDev? What are you doing? Like custom reflection system? Yes, exactly. We're doing a custom screen space reflection solution, which we're initially going to be using for the water, but eventually for a lot of different other stuff. So if it was only for water, then we could probably get away with a lot more artifacts. But I want to use it for glass and stuff like that as well. For performance reasons, mostly because we want to handle the outlines ourselves. So we can't rely on, if we would have gone with some Unity or like the, what is it, first party Unity solution, it wouldn't handle outlines, so we would have to customize it. And we're gonna extend it in more ways than outlines. So I do really want to have, it's not so much that I want to have, I must have my own solution, but I need to fully understand exactly what's going on so I can tune it and extend it however I see fit. But it's mostly because of the outlines, right? What's up, Luke? The shaded grind never stops. Yeah. Indeed. Should have that on my wall or something like that. Okay, so this is acceptable for a first iteration. I'm a little bit worried about this one, but we could get around it by changing the steps here, depending on the angle of the ray, right? Udev, let's hope after this one you will not decide to make your own game engine as well. Believe me, I've been wanting to, but nah, that's my limit. So if we have a ray that travels a lot of pixels, oh, let's see here. Like, look at this one. If we do a second pass on this one, we would probably get a very good result. Okay, let's see what our second pass can do. Okay, best intersection score is 0. Rather, guess we could do, if best intersection score is bigger than 0, return, or yeah, no, not 0, but 10. If it's bigger than 1, return 0, otherwise return 1. Let's see. Okay, we'll remove some here, but 0.1. Okay, we can't be that rough with it. 0.5. Okay. And let's do stop count and best intersection step number. Step length, save stop 0. Step count 1. I think this is how we want to do it. Current depth, scene depth. We calculate depth difference if it's less than depth threshold, second pass, return 1, otherwise 0. Oh, one sec. We need to do... pretty much the same artifacts that been screwing with us for a while, I would say. Definitely. And this one, I had high hopes for second pass as well. This issue, so we have this one and this one. Let me just do this. One sec, why would we get this result? So the ray hits here, we reflect it. At the reflection point, our view depth. Oh, could it be? This is our reflection points. The first step, we end up behind the character. We're extremely far away behind the character, but this is the best reflection because where we hit it here, at this point, we're extremely close to the ground. So we're gonna walk that one, but if that's the case, then we should get rid of it if we do this, and we do, so that's good. We have had better results than this with a previous solution. What is it? Scene color, scene texture. Oh yeah, we have a weird scene sampler for this one. Is it sampler, scene texture? Looking pretty damn good though. We're getting closer. Definitely. Losing a lot of FPS though. Or frames, I would say. 224. This one, what the fuck is going on with this one? This object has been a problem in pretty much most of the solutions we have tried. And I'm still not entirely sure why. Noted, no bed allowed on water surface. I wish I could like add constraints like that. Ooh. Overlapping. Yeah, this is probably... I think we have tried like 5 different approaches to finding the intersection. And this is probably just right in the middle. It's not the best one yet. Frustrating. Frustrating. I think the best one yet is probably... I want to do current depth vs is less than or equal to current depth seen. Fuck, can we do this and... No, not current depth seen, but depth bounds.x and depth bounds.y, or actually current depth seen depth bounds.y plus threshold first pass. I want to try some things with this, but ooh, so this one right here, it gets a better score up here than it does here. Oh yes, that's true. But if we do return 1, this one is always true for the first step count. That sucks. So let's do step count is equal to step length. Oh, never mind. 0.01. having a hard time deciphering what's actually happening here. This ray intersects with this one, I suppose. Let's see here. Here we have it. So this point is this point. But what happens here then? What is this? I wonder if it is depth bound x is less than I wonder if it's the fact that we only measure intersection from or one type of intersections, so it's basically, yeah, probably. So let's see here. Either that we measure when a ray intersects going from outside of an object into an object, but not the other way around, or that we measure the other way around, but not a ray going from outside an object into an object, if that makes sense. So how can we fix this? Because this bed artifact, like, and I'm talking about these big lines we can see here. We have to get rid of those, because like these things we can probably fix by having a dynamic step length. So depending on how the ray is angled, we bring it down. We can have a dynamic threshold as well, make them thicker and whatnot. So this we can control. This one is a little bit tied to these things, but I don't think it's fixable by changing. We could probably get this best case scenario, this one worst case scenario. So yeah, I would like to minimize this one in some way. Let's see, can we do... I just want to see if it's what I think it is. If it is, we should be able to do... Let's see here. Bool intersect 1 is equal to this. So how would the other intersection look? It would probably be... Bool intersect 2 is equal if depth bounds dot x is bigger than or equal to current depth seen, and current depth seen is bigger or equal to depth bound. Start. So is if the minimum is bigger than this one, maybe. That made no difference whatsoever, right? Oh, maybe it did. Maybe not. Okay, so this is interesting. Yeah, because we don't want to... Never mind. I wanted to disable the second pass. I disabled every step after the first one, so that explains it. Yeah, this banding is so manageable. This banding is not. It's the same problem we've been having for a while. This is more like something I would like to see, but of course with like this. But with better performance, of course. Yeah, it's the damn thickness of this one, definitely. You'd have one satisfying thing is the changes take effect instantly. Yeah, I love it. I love it. Yeah, so that effect is 100% tied to step length, and it's because... Okay, for this point we get an intersection with the mattress. For this point we don't get an intersection with the mattress, and that's something I want to solve. Which is why we started today with doing the check comparison between previous step and current step, but that didn't really get us that far, honestly. But can I go back to it? I removed it. Let's do bool intersect 3 is equal to previous current depth of scene. We do so this one again. Now we don't have we don't get the same banding effects, but we do get fuck, this one is, if we can clean this up, this one is probably the best bet. We just have to make the second pass not make the same mistake as the previous one did, right? Sadly you get disappointing result also instantly. Yes, indeed. But do we want a mix between the different solutions? Maybe. 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 Let's see here. Honestly, I think we have to be less conservative of where we start and end the last or the second pass. But if we're too loose with it, we're gonna end up with a very costly second pass. So if we take a look at the second pass again, we miss these and we have some overlap here. So we miss these and we have some overlap here because we take the wrong score. And that could probably be because, yeah, we solely do best score, we don't have any order of it, basically. You could probably do score. We want this one to be as small as possible. We could do it like this. And add a multiplier value or something depending on how far we have walked. But yeah, that's something we want to avoid. We can also see that we have some flickering going on here. I think it's because our sampler is not doing its job, so I think we can't rely, if we use this type of sampler, I don't think we can rely on this macro maybe. But I don't care about that problem for now. This problem we want to... Ooh, yes. Yes. We want to do, let's see here, Insight 3, previous depth VS is less than previous depth seen. This one is not true and this one is not true. We need to do a... Let's see. We could do it as simply as... let's see if we can get rid of it by doing this. Previous... float start depth. One sec though. Okay. This is also a problem we've been dealing with quite frequently. It's basically the depth difference at the initial reflection point between the geometry that is underneath is extremely small. Luke, would this shader work for sideways reflections as well, or at least easily repeatable once done? Not entirely sure I understand what sideways reflections are, but like it is a screen space reflection solution, and that comes with a lot of drawbacks. We will always only be able to reflect whatever is rendered to the screen. A perfect example of that is this sphere here. As soon as it starts going outside of the screen, our reflection starts disappearing as well. We can do some things to minimize this. We're going to get to that eventually, I hope. E.g. glass on the wall, mirrors, etc. Mirrors would be extremely weird, because if this character would be facing a mirror here, we would reflect the backside of the character in the mirror. It would pretty much work if we have, let's rotate it here. If we would have a glass wall here, we could probably get away with this reflection. This would probably reflect quite well. But like the idea with this, this is just going to be used to add extra flavor to... We don't want to use this on extremely smooth surfaces, so like mirrors and stuff like that. We want to use it for water with a lot of noise, you know, waves will refer... Like, what I'm trying to get at is that we're going to rely on the shaders that use this to properly distort the reflections so much that it hides most of the artifacts. But with that said, I do want to get rid, like, I still want the result to be okay-ish without distortion. We're mostly going to use this for water, and then we're going to have we're going to use it for reflective surfaces that are that has some roughness to them, basically. So reflective surfaces that are not thinking here. I think some of the examples I gave was water, of course. You could have it for glass that is, you know, low quality glass, the old school glass you had when you made it by hand. So it's it distorts reflections a lot. We're going to use it for, if we have a monster that is some kind of blob that has some reflective properties to it, we're going to use it for that. hopefully it will become a little bit clearer once I can actually showcase it on water. In other cases, sorry, I misread that question. In other cases, we are not gonna have reflection pretty much. How to count on water and glass has this funny thing where the angle determines how much reflection there is. Straight on, there is pretty much no reflection, and at 90 degrees, it's almost 100% reflection. Oh yes, and we love it, right? Yeah, it's usually, I don't remember exactly how it is, but it's pretty much for water, for instance, where we have a high specular value, that is where we're going to see reflections, I think. So the higher the specular value, the more reflections is going to be visible. I think. I'm trying to calculate it in my head. But so, yeah, as to the question, Luke, what would you be using in other cases? Like, reflections has always been a big problem in game dev. I think ray tracing is pretty much helping a lot with it these days, but we're not going to do ray tracing. So I'm going to try and avoid reflections for anything that won't be able to produce a good result using screen space reflections, basically. Okay, so as to this issue, I would think we could pretty much get away from it by doing step length here. But look at this, we still have this issue. Honestly, I'm starting to feel a little bit like hitting a dead end, which is sad. So the best result is pretty much this one, right? Yeah, except for the first one here then. Return 1, return 0. I think this is pretty much the best we have so far. Yeah, apart from this artifact though, but that should be easily solvable. And then if you add a second pass here, what do we have? Score. We don't want to base the score on this anymore. We want to base it on or do we? No, current scene depth minus depth bounds X. Current depth scene minus depth bounds Y. Or rather, we would like to do something like this. We don't care about best score, but we want to break, and then if we want to break, and if what are we getting here? If this is true, we break, and hopefully we would go on, but we won't if we have this. Yeah, okay, that explains it. The initial point, so the point where we reflect the depth to the underlying geometry, is extremely small, so we always return that one as our intersection. We want to avoid that. This one doesn't help. If we remove this one, I think we should. Yeah, what's up, Diligence? A new week, a new render feature. Not really. A new week, the same old SSR grind. As far as the SSR goes, I think we've pretty much hit the dead end. Currently. Luke, best of luck to you, Robin. You can beat this roadblock. Thank you. Appreciate the kind words. Hopefully. Oh yeah, one thing I forgot. I'm pretty sure we need to do this. There we go. And yes. Hmm. $250 FPS at this result. It's okay, I reckon. It's this one that bothers me the most, again. Like even though we would have a moving surface that reflects, this artifact would be hard to hide. We see a similar thing here, of course, with the pillow. I hate this so much. But if we step 1 here, we get a pretty good result. pretty good. Extremely bad performance though. So this is pretty much, we just walk 1 pixel per step. But then again, yes. So 1 pixel. So a small step in screen space might be a big step in view space. So we want to like if we, let's just say, or if we accept the fact that this is probably the best intersection method we have and focus on the details of this intersection method. So what I'm talking about is specifically this one and this one. So I'm gonna draw this again for the, I don't know, 3rd time maybe. So this is the ray in screen space. So we have a screen here maybe. But this ray in view space is this one. The step length is 100% based on the ray in screen space. So when we have a setting of 10, that means that we walk at least, we walk 10 pixels in the dominant direction or the primary direction on this one. But 1 pixel step for this ray is actually a very long step on this pixel. So the depth difference between this point and this point, even though it's only 1 pixel here, can be extremely big. And right now the intersection algorithm we're running with is we step through this one, but this one as well, and we take D1, D2. We always have 2 depth values of this ray, D1 and D2, and always on the second one we also sample DS, so the depth of the scene. And we have an intersection if D1, DS with some offset as well, but pretty much this. So that means if the depth of the scene is bigger than the previous depth we had, that's not entirely true either, because let's call this one P and this one C. We calculate D1 and D2 by doing if dP is bigger than DC, then D1 is equal to DC. and D2 is equal to dp, else D1 is equal to dp, and D2 is equal to dc. So pretty much we always have two depth values, the previous one we sampled and the current one we sampled, and we always want to figure out which one of these are the smallest, and then we compare with the current scene depth, and we check if the current scene depth is within these, then we have some form of intersection. But it pretty much relies on the assumption that whatever object we have here that gives us ds, that we pretty much had this exact same object for dp at the exact same depth from the camera. I think this assumption gives us some of the artifacts we see. Although I'm not entirely sure how one would work around that. But yeah. But what I'm trying to get at is, fuck, we did another solution that might actually be better for this case. That might actually be the best one. Oops, sorry about that. So instead of relying on, we actually did a solution as well where we stepped through the view ray, and instead of relying on the previous point, for a sample point here, we went along the line, we just added an offset, so we get two new sample points, and these two sample points are our new dp, even though it's not previous, and d current. I don't know why I think it was a question of optimization, because here we pretty much add one extra interpolation, which we don't need to do here. But with this solution, we have a way more control over, like, the previous point, or D1 and D2 here are locked to the step length, and not the step length of the view ray, but the step length of this ray. While if we did these offsets instead, we actually have we introduce a new variable here, which we can call O for offset maybe, or just C. We get a new variable here, which we have a lot of control over. So for instance, depending on some of you who watched my stream on Thursday, I think it was, will recognize this, but we could base C on the angle between screen ray and view space ray, because the bigger the angle between them, or or the smaller the dot product between them, the bigger difference between them. So that means a small step here equals a big step here. So if we have a dot product, or the smaller the dot product we have, or let's see here, let's go with the angle. Let's constrain them, or take an assumption that this is the worst case scenario we can get. So we can at most get a 90-degree difference between them. So the bigger this angle is, the bigger of a difference we have in step sizes. So if we walk 1 pixel, 90 degrees would pretty much give us infinite, but if we would have a case where we have this angle, I don't know what it is, $70 maybe, but 1 pixel step here is this length in screen space, but it might be this length in view space. So in view space, the depth difference here is extremely big, or can be extremely big. But if we go with this solution, that means that we could do, we could base the C on this information, and how do we want it to be. So if we have this difference, we probably want a smaller relative movement on this array. Yeah. So let's do it's this one, get ray depth VS. We're gonna do this. Depth float min depth VS is equal to get ray depth VS ray, and here we're gonna go T minus some offset. We can use, or we used jitter previously, I think, so let's use that one again. Minus jitter, we'll float max depth VS. And then we do, I want to copy this, let's comment it out. Min max, if max is less than min, then we want to change them. And then we use depth bound for intersect, and we do the same thing. If intersect 1, return 1, otherwise return 0. Yes, and what do we have? A jitter 0. If we do 0, we get this. We have a step length of 1, so good result, bad performance if we have a step length of 2, 3. And this is the case, or this is the case where the view space And let's see here. The reflection ray shoots. Yeah, it might hit here and just go out towards the horizon. So an extremely long ray in view space, extremely short ray in screen space. So we start seeing these artifacts because... So depending on this result, we might want to make jitter bigger, yes. But definitely not too big, like we can see here. So if we make jitter bigger, we get good reflections here. And the opposite way here. Here we want to make jitter smaller, otherwise we get... I think this is what we want to do. But then again, now we have a step length of 3, so if we have a step length of 10, we get better performance, but we still get these. Could we save this? Yeah, if we go with a bigger jitter, we save it. Yeah, fuck, this is what we're gonna do. I think we can solve it. We have this issue, and once again, this is because the underlying geometry screws up the result. If we can get rid of that one once and for all, we have a pretty free playing ground to improve this one. Yeah, this is what we're gonna do. Okay. But I also want to show sample texture 2D. We get pretty good color values as well. Yeah, we can definitely go with this one. Gonna have to do a second step, but that's okay. Yeah, this is the best solution, definitely. A little bit worried about this. But okay, let's worry about this one first. So this one right here. Yo, what's up, Cooler SK? Hope you had a wonderful weekend, man. This one. So imagine this. We have our reflective area, we have our ground, or actually we get this reflection. So when we do it for the first point, we interpolate upwards and backwards. We get this point, and then we get this point that doesn't exist, and then we can see that scene depth, because we have the ground here. And the ground, so scene depth is, or actually it's this one. This one is definitely, the depth of this one is definitely between these two. Or definitely is not a term I want to use here. But I think that's it. We go too far behind, basically. And that's why we need to saturate these two. If we saturate only this one, Then we solve this, but we get this shit. That's rough. This one is not solved. Why do we get this? Saturate. Coolers came aching all over. Why? It feels like that's a answer that needs a B attached to it, you know? Say A, you have to say B, and so on. Okay, so we solve the ground problem, but we get this problem. Why? Saturate. We get 0 here instead. So we get the reflective point. Oh, do we want to use this one? Yeah, we do. Okay. Washroom repairs. Oh, nice. Productive weekend then. Okay. Yeah, the saturated solution is not something we can rely on. What can we do instead? What can we do instead? Cooler holiday here today, but I'm planning to do at least something more today. But no heavy lifting today, I hope. Good luck, man. Good luck. I hate this one, like... Could we add a constraint that the depth also needs to be... that the depth also needs to be bigger than whatever depth we have at the reflection point? Could that solve it? Needs to be bigger. But that means... No. That means that if we have an object... If we have a reflection array, but will we... If we have a reflection ray that goes towards the camera, we're probably not going to be able to reflect something good there either way. I just want to see what kind of result we get. Float min depth scene. And then if we add intersect 1, all of this needs to be true, and I wonder if we just care about the smallest one. Yeah, that's true. Gotta reflect here, up here. Okay, it screws us like that instead. Ooh. We could do... What could we do? saturate here felt. Oh. Saturate here felt like the correct answer, but if we saturate this one and then don't do anything here, if this one is big enough, we're gonna get the same issue. Cooler SK, we got a full coat of snow overnight. It's still all white outside. Nice. Is it the first snow for this winter season? Yeah, it's probably gonna be at least a couple of weeks before I see the first snow, I think. I live in the south of Sweden, and the snow we get in December, it's some mix between snow and water. It's just incredibly boring. It snows, but everything just ends up wet instead of getting that nice coat you want. Does it exist anything we can do? Yeah, we don't want this solution, at least, that's for sure. Yes, okay. So we have these working against these, basically. I guess we could do... let's do this. Nah, we can't do it like that. This is normalized, so between 0 and 1. This is in view space. So world units, pretty much. So we can't do it like that. But I was thinking that based on the result of this, we limit this one. Something of the sort we could probably do. But then we need to figure out how much does jitter, how long in view space does, what's the ratio between jitter and view space distances? Yo, what's up, Ascrit? Living the dream, my guy. Trying to, at least. Our biggest problem now is definitely if we have a view space or view ray, we have the problem of sometimes going too far back and sometimes going too far forward. And that's what we're trying to solve. background violence indeed. I hope the phone was okay or whatever that was. Yeah, hopefully. One sec. Yeah, it was okay, it was okay. And it was a phone. Spot on. That is, yeah. What we could do is... Fuck, can we do this? We also have the problem of that one ray is... Or we have a projection to keep in mind. In screen space we have applied the projection, in view space we have not applied the projection. So interpolation, that's why we have this method. It's projection accurate interpolation. A dad can hear an expense 100 kilometers away. Yeah, that's just something one has to get used to. I'm starting to feel that we're very, very close, but this is the first. We have a few hard problems left to solve, and this is the first of them. Hopefully the hardest. Yeah, so it's basically we want to limit it here, and we want to limit it here. Yo, what's up, Catboy King? Because I think, let's see here, this is an issue of us going greater than 1. This is an issue of us going lesser than 0. If we can solve these two, we have a pretty good foundation. Thickness here. So if we would do this, and we would go with a thickness of 0, is it this one? We get this projection issue when we go below 0. That's bad. And we get we still have this tiny. Why is that? Okay, maybe it can help if we figure out why this issue. So we saturate this one to between 0 and 1. So in this case, this one will be 0. So we get the start of the point. So let's say for the first point walking along the ray, we have this one is equal to the start point. Current depth seen is definitely bigger or equal to this one, so that's true. And this is also true. What is this true? Yeah, it is. And we go, this one is 0. This is true. This is most likely also true. So we get an intersection. But one sec. No. For this point, this one is definitely true, right? Depth of the start ray is... The start ray is always going to be closer. So for the first step, this one is always true. So this one fails. Does that mean... Yeah, this helps later on. Okay. So it's this one that is the problem. So what happens here? Do we have a problem with 0? T is 0. Would a better option be to do okay, so it's not doing the interpolation with 0, that's the problem. I'm dreading when we're gonna apply the outlines as well. Probably gonna get some artifacts with that. I just have to double check one more thing. So we have the line roughly here. Let's do... Yeah, that's exactly where we start walking. Or actually, it's the point where it's not the point where we go backwards on the ray, because we actually do that here as well. It's just that we don't go back enough on the ray here to intersect with the ground underneath. Yes, so if we saturate these here, I don't know, I don't think this is a problem, but I'm just wondering, do we really need... Probably not. how does limiting the start point at 0 screw this up? Like, it pretty much gives us a projection error. I'm starting to think that this comparison like it's mostly it avoids but one thing, if we don't use that one, we only use this one, we're still getting this projection issue here. Interesting. So would that mean if we limit this one to 0, that means that the first point has the same position as this one. Fuck, I guess we could do but I want to do not 0, but 1. If this is true, continue. Then we don't need to saturate. Yeah, of course. So, what options do I have left? Definitely need to add a we could probably do. I wonder if the could the issue be these are 0. Could we do something with oops, not that one, but I want to change this one. What do we have? I guess an easy save would be step count is equal to step length, then we lose. Ooh, interesting. That is interesting. Okay. We get this. So what we're doing now is that we step count, we step. Okay. Like we skip the first part of the reflection ray, but this issue still exists. Okay. Because by skipping the first step, step count should, so the first step shouldn't be at the start, but rather pretty far from the start, which means that when we interpolate along the view ray, we don't go through the reflective surface. But the issue, or the artifact, is still there. This one is still true. Could we do it? Oh. Could we? Could we do? We calculate a new t minus jitter, t plus jitter. And then we calculate a new middle point, and that is the... Oh, fuck, let's try it. T min, saturate. So do this, and then we do (0.5). Then we have a T mid. Ray current point. Get ray point. With offset. Get ray point lerp. Yo, what's up, Hercules? Hell yeah. Unfortunately, hell yeah. And here we just do a lerp ray start SS. Fuck, I hope this works. So we pretty much do a correction. So we get the T mid. Fuck it, let's do float current point SS. Current point SS is equal to get ray point lerp SS. ray, and then this. So I want to try this, but let's say we have this ray, we get to this point, this is the middle point, we do plus jitter, minus jitter, this one is outside, so we saturate this one to here, and we recalculate this middle point to be here. And then we do T min here and T max here. This still leaves us with this problem later on, unfortunately. We still have this issue. And we still have this issue. Hercules, do you ever develop a game in a team? Nah, nothing serious. I've done some game jams, but that's about it, I think. It's pretty safe to say that I'm misunderstanding something crucial about this. The actual issue we get here. Definitely. But what? I don't get it. I don't get it. Oh, so good reflections. If we're outside of those limits, we have pretty good reflections, except for this, but this will hopefully be saved by basing this one on the reflection angle. But yeah. TubeDev, it's not too late to make your game have a fixed angle camera. Believe me, that idea entered my mind for like a millisecond. That's like how tired I am of this screen space reflection bullshit. Or just like fucking real-time probes would be so much easier as well. Would love to dive into RTX as well, yeah. Would be nice to be able to rely on that. Still want to have some nice reflections for people without RTX cards, you know? Okay, let's try and understand this. Yu Xiang, sorry about the pronunciation, but what's up? How are you doing today? At this point, we go backwards on the ray, and that's a big problem. If we saturate the ray, or we saturate the T, we get another problem. Or, sorry about that, if we saturate the ray, we get this problem. But if we don't saturate it, we get another problem. If we don't saturate it, we get a intersection with the underlying geometry, and that's bad, very bad. If we do saturate it, we get a hit. Ooh. Okay, so if we don't saturate it, we get an intersection with the ground. If we saturate it, we continue, and we get a fucking intersection here. How does that make sense? Or rather, we get an intersection at the first possible point, right? That's what we're seeing here, isn't it? But, okay. Okay. If we lower jitter here. Okay. Okay. Okay, so that's the problem we have. Basing the jitter on angle might actually solve both of these issues. Okay, so this is not a problem of... This is not really a problem of intersection or going on the negative side of the ray or anything like that. This is more a problem of the C. Where do we have it? Of the C here being too big when we have a reflection angle like this, because this is basically, if we look in this direction, the reflection ray, where do we have it? Here. It lines up pretty damn well with the screen space, while we have a reflection like this, a steep one, it also lines up pretty damn well with the ray. And if it does that, then we want to have small. No, we don't. This issue might be another one. I think we would like to have big here. But if we have something like this, we would probably want to have smaller jitter, but not too small. Or would we have, maybe if we do 1 and 0.1. Yeah, we're gonna have to find a perfect, oh fuck, this is gonna be rough. We're gonna have to find a perfect ratio between these, I guess. And step length, we need to take that one into account as well. Fuck me. So it's pretty much going to be... Can we tie... Okay. Okay, let's do this. T min T max. Current depth vs. Current depth. No. Current point SS is equal to get ray point lerp SS ray lerp T min T max 0.5. Mm-hmm. Okay. The problem we have here is that we still offset 0. I wonder if we could figure out a relationship such that let's see here. So for this angle, we would pretty much go down to 10. Are we still getting 250? That's pretty damn good. 5? Yeah, because half can't be seen. Okay. Okay. That's pretty good. Not perfect. Jitter. Do we want to go... Fuck yeah, we want to go bigger in this angle, but... We want to go bigger with jitter, and I think this one want to go bigger as well. The problem being, yeah, we want to go bigger here as well. The problem being that we get the ground look through again. But if we can figure out a good relation here, it would be. But then again, what kind of ray do we have here? We want to go way bigger here, right? Yeah, we do. Okay. What can we do to save the visuals of the ball here? 20. Okay, that doesn't help. Okay, let's just focus on one first of all. Jitter, if we go higher. So 1. Works very good for this type of race, extremely bad for these, so let's see here. I want to see. Let's try and calculate. So I guess it's the ratio, or pretty much how much in the Z direction, or how much depth does one step here correspond to for this one. And unless I might be gravely mistaken here, but we should be able to do some form of dot product or something like that. The angle I talked about previously. I wonder if it's... I'm just trying to think about all the different projections and stuff we're going on. Would it be feasible to just add a z equals to 0 to this one and do a dot product? Or... not really. We have, so this one is actually in a screen space that looks like this, which means moving a little bit to in X, but we normalize it to be squared. So we have that problem. We have the whole projection problem. Anything else? But I don't think we might not even need to take the screen space into account. We just want to know could we do the total length of this ray, which we already have, divided by the total length in Z, or something similar. So if we have a view space ray that doesn't move at all in Z, we get 0. If we have a view space ray that moves only in Z, we get a 1. I want to print. I wanna render that just to see how it looks. So we have. Don't we have create screen space ray length in world space? Unfortunately, But I guess we could do I guess we can do a float r. R is equal to but we have to be careful here. Minus or a negative space here. Oh. So if we're in negative, let's see, 110 minus 100, it should be okay. But we do R divided by length in VS. In fact, let's print this and just see what we have. Undeclared. Oh yeah. Ray dot. So 1 here. It means that the ray is pretty much aligned with the view. Here we have 0, it's not aligned at all with the view. Are we moving towards the camera at this point? Nah. Do we have... What do we have here? Here. Yeah, it's the line that gives us the most problems. So this line here is this one being 0 or extremely close to 0. Ray end in Z, which means that end VS and start VS. Is extremely close to each other in Z. So Ray shooting out here, we're pretty much going straight up, I guess. Not moving any. But I'm not sure how true that should. This pure black here pretty much, let's do this. Return ray dot r is less than 0.001. So for this point, fuck, I want to do. Okay. So at this point we're basically moving only in the X and Y direction. The reflection ray is only moving in the X and Y direction, and just a tiny bit in Z. So does that make sense? I don't know. I guess it does. In fact, let's do. Where do we have it? So let's make it easy for ourselves. Let's do this. Roughly here. And where do we have? Nah, I don't buy it. Or do I? It's relative to x and y. We could probably do a better... Fuck, why didn't I think of this? We could probably do... We could do... We could set R to be... Instead of this dumb calculation, we can do is equal to, let's do dot. Ah fuck, we had length in VS, never mind. But we can do dot between direction VS. And -1, I think. And then do... Actually, let's return R. And we do this one times 0.5 plus 0.5. And that's more like it. Fuck, we're running this from the back side. Ah, whatever. So the bigger this one is, the smaller step length we want. So I'm wondering, let's do step length bounds. Ray R step length ray.r. So this is 1 if we're steep. And if it's 1, we want to do lower. So if we're at this one, 1, otherwise 20, I don't know. Okay. So here we're going with 10, 20. Okay, so this is the worst one. 2. Okay. And then if we do this, let's go here then. It's more towards this one, right? Yeah, looks to be. This one, which we want to fix, maybe. I'm starting to think 215.5. It's not that much gain. Yeah, this is not going to be used for. Oh, actually, 520. Okay, it's pretty. What do we have here? 160. But yeah, we don't want to do this for performance reasons. We want to do it for we want to do it for remove some artifacts here. This one is rough. 5, 2. We might not want to do, sorry about that, linear interpolation here, but we'll see. Around, this one is rough. Okay, but what I really want to do, let's just do, okay, let's go with 5 from all angles right now. What I want to use this one for, or the R that is I want to change the, I want to avoid this one, and this one is tied to, I wonder if it's tied to both jitter, definitely jitter, so 0.01. Here we want to go smaller smaller. So we want jitter to be if we're at this angle, can it be bigger? Yeah, it can. Okay, this is fucking great. So if we have, if R is big, we want jitter to be big. If R is low, then we want jitter to be low. Okay. But I don't want to name it jitter. I want to call it artifact prediction variables. I want to call it T. T offset is what it is, but I want a more descriptive term. This one is pretty much used to it's used to create a segment of the view space ray. So portion, segment, portion. This one pretty much decides this one. So it should segment thickness or something like that. Segment, yeah. Let's start with that one. Maybe not the best name, but or just this one should probably be thickness. And we want this to be a vector as well, and we're gonna go with I forgot. So if we're at this angle, we want it to be if R is big, we want it to be 0. So here we can probably go 1 0 0 0 0 0. One as a default is extremely big. 0 point. So what do we have? Segment thickness 0.1, and here we're at. Here we should be at. Here we're at 0. Okay, 0.1 way too big still. 0.1, 0.01 works. Here I would say. We have this artifact going on behind here, you can see it. But Here we get this one. That sucks. Why? But if it's this small, then there's pretty much no... That's what we want to avoid. Wait, am I misunderstanding something? Shouldn't we have this one here? Or do we want it to be... The fuck am I missing? One sec. Oh, I'm tired. Segment thickness, where do we have you? We have it here. We just used this one. What the fuck? We need to do step length. And we're gonna do float segment. Here we can call it T offset. And we do a lerp. Segment thickness x segment thickness dot y ray dot r. So here we want it to, here it should be this one, I think. 0.01, 0.1, way too big. Isn't it this one here? Actually no, 0.1, 2, 3, 4. Fuck, I have to double check. Return ray.r. We should have one here. Pretty much. So it should be this one. And then we have dark here. Okay, we never go. So here it's ray segment Y. But how big can we go here before? What am I missing? Why are we not getting any change here? Because T offset, we want to use this one here as well. Jesus. Okay. Do we want to go big here, but not this big? Maybe this. And then if we go here, we can start seeing a lot of artifacts here. So we pretty much want to lower this one, but yeah, no matter how low we go for this one, yeah. And we get this one. Are you crazy? Yeah, we need to do some other lerp. We're not moving quick enough here. We're not moving quick enough, so let's do ray R. We want to remap this edget. Remap, let's see, util math. We want to remap it from 0 and 1 to, fuck, if we're just gonna do a remap like that, we could probably just do 0.5 times. No. Or yeah, I don't think we want to do that kind of remap. I think we want to do a remap like to the power of or something like that. Let's see here. We want it to become smaller quicker. So we should do pow, right? 2. Better, but not good enough. What the fuck? If we have 0 here, we want something like this. The problem being, we want to avoid this one showing up as well. I don't know if we go higher. Fuck. Not entirely sure about this one though. This is crazy, because if we take a look at this one, here we have a lot of artifacts by the pillow, right? Maybe this one isn't the one helping with it. If we had 0, we still wouldn't get so is this our depth here we want to do? No, it's not. Or I don't think so. So which one? Segment thickness. Where do we have? We want to go we want to go high here, high as fuck. But we want to go extremely low way quicker, right? Almost instantly. This is too much. I could probably go... One sec. Yeah, this is a problem that we don't decrease quick enough, right? Hell yeah, Cooler SK. We're very close to at least. Fuck, not a big fan of this distortion we get here either. But maybe it's not too bad. This one sucks though. I want to see... Back in my day, they used to just do second cam with flipped image in it and rendered into surface, worked fine. Dude, back in my day, they just copied the object that was going to be reflected, pasted it on the other side of the object, or a transparent surface. Yeah. The last thing I want to do is reintroducing a second camera. Although the result would be pretty good. Okay, so what is the issue we have here? Is it because we're not moving? Oh, it's because we're moving too slow. Interesting. 5. But if we're moving too slow, then we get something like this, and that's rough as fuck. Or rather, let's see. Pow, 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 pow. Yeah, 10 cameras. Like, in a perfect world, we would probably do it with, what is it? 6 cameras in each direction, so we can recreate a cube roughly around every object that is going to be reflected. I wonder if we can fix this one with changing this one. If we do 0.1, yeah, then we get more, but if we do 0.2, then we get less. Yeah, okay, so we want to do this one as well. We want to introduce this variable into the ones that depends on the camera angle. Fuck, we're starting to get a good result here. Get some artifacts here, but that's okay. Oh, feels good. This as well, but whatever. Performance is shit though. That's not good. And if we go higher here, we're gonna have a lot more. Would love to have this at 20, 20, 20. Let's see here. 1, 1, 1, 1, 1, 1, 20. I will get this distortion from this angle. Yeah, if we introduce depth threshold first pass. Okay, so if we introduce this one, so we go more or less raise with this one depending on angle, we might get away with a lot more. Okay. Okay, so let's see here. We have T offset, which we use here. Then we do this. It's this one. I think we want to base this one on step length bound. What do we have? Segment thickness, depth, thickness. We're gonna go 0, 0.1, 2. Let's see here. If we're at this angle, okay, then we're doing this. Ah, fuck. It's definitely more this one. What do we have? 0.1, 0, 1, 2, 3. I want to avoid this. But the more we go like this, I think we want to go like this, roughly. Okay, what do we have? Performance 180. That's not good enough. Okay, I'm pretty sure we can play around with these settings and introduce some more. But I'm gonna have to do that tomorrow because I gotta run now. Getting closer and closer, definitely. Still not exactly where I want to be though, but yeah. Let's give it another day because I've got to run now. But thank you so much for watching, everybody. I appreciate it, and have a great rest of the day. Peace.